Okay, welcome back to everybody. We're doing today the paper autopsy of PST2. So, this is like the Project Phoenix second paper. So, I think let's also be like a phoenix. Let's not slack off and let's do it. Okay, so honestly telling you, paper autopsy is one of the most interesting things you can do with your mock tests because it actually works and it might be a sword or key to your neat lock. Okay, I don't want to talk philosophy, let's just dive into it. This question paper is actually mine, and definitely there are a lot of wrong physics stuff because I don't know what I was doing, and please don't judge me, like physics is my least uh, confident subject, so please do not judge me, but I think we're gonna go with it. We're gonna do every single question, and we're gonna. I think error hunt and recovery art will follow after we finish every single question. So let's finish the 45 questions first. So I'm just taking a book. I had a lot of books during this NEET preparation, so I'm just like filling in stuff that I left between, and I'm gonna be practicing every single question again. Now, why am I doing this? First off, I'm not good at physics, so I cannot trust myself just because I've done a few mistakes. Because I think everything that I learn right now will matter anytime in the future. So, I'm gonna go with the first question. So, a wire of length L is stretched by a force F to cause an extension X, and another wire of same material and same volume but 50% larger in length than the first wire, the force required for the same extension will be. Now, let me tell you something how important it is to read a question. I think, yeah, somewhere here you can see that I've made a huge blunder because, guys, they've told it's firstly, if I have to decode it properly, length L stretched by a force cause an extension. Okay, so you could draw it if you have your book that initially there was a rod with length L and you put in some force. Okay, now they've told there is another wire, but it's of the same material. So what remains same? Y remains same. Young's modulus. Same volume. If volume remains same, that means A1 L1 will be equal to A2 L2. Simple. And they've told it is 50% larger in length than the first wire. The meaning of it is L2 is L1 plus 50% of L1. So what does it mean? It's not L2 is equal to L1 by 2, but L2 is equal to 3 L1 by 2. That's the meaning. See, first off, they've told 50% larger. So in that itself, you need to understand that it's definitely a value that is more than L. So it has to be, you know, 3L by 2 because it can't be L by 2 because that means it's lesser than the actual value. So this is one blunder that I actually did. But next, after doing that blunder, I kind of realized and I did the right steps because force is, they're asking force. So you need to, F1 is F, but they're asking F2. So altogether, you need to find the force, and if you kind of substitute everything, you're gonna get the answer, and it's pretty evident and easy. And also, guys, there's another formula like to not get a lot of confusion that they put. Now you know y is equal to f by a delta l, like l fl divided by a into delta l, right? But if you need in terms of volume, you can write f by v and L square by delta L. Okay, I think it's better to know this, at least have a glance of it, because sometimes if in the exam they suddenly pop this out and you'll be like, wait, is this even formula? Yes, it is. Okay, moving on to the second question, which is actually wrong, so please don't see whatever I've done. It is again a huge blunder. But we're actually going to decode it right now and see where exactly what we've gone wrong. So the question tells a cylindrical rod of radius r on the ground. Okay, I'm imagining a rod on the ground supports a load of W, experiences a compression of E. Now, this is where I think I got a little bit confused because this is initially how I did the diagram, but I don't really know how they mean compression because of the load being there. So, let's see. I think this is right. Yeah, right. Okay, if a cylindrical hole of radius r by 2 is drilled coaxially and it now supports the same. Look, now let's take the same rod, but it's kind of hollow because you've taken out a cylindrical portion of it with a radius of r by 2 and you're putting it through the same situation. Now, what is the compression is what they're asking. So, I think I'm really good at visualizing it because I think the diagrams are very right. But if I go wrong in the visualization, I think that's where I go wrong with the whole question. But all right, in the first case, A is 4, pi r square. I think that one is fine. In the second case, it's right. What I've done is right. In the second case, it is pi r square by 4. Like you basically remove this. So you have the area of 3 pi r square by 4 right now. Okay. Now, coming to the most important, I think this is a part of the chapter itself because I think I've seen it once again. I just need the book because I promise you, I think I've seen this formula in the NCRT textbook. Let me go get it for you. Okay, I'm back. I'm back. I'm back. I'm back. Um, Solid mechanics. Because I don't know if you remember, if you've seen, there is this thing about a beam which is supported at the ends and a load is in the center, and I think it's almost the same because weight is the same. But in this case, there is bending and sagging, I'd say, but the actual compression part is not there. But the usual formula they've used is y is equal to f by a delta L by L. Okay, now this is all they've done. So I am supposed to get the answer. I got it as 4, but okay, fine. Let me check it out. Okay. Now this is 4 pi r square. Sorry, pi r square. Oh, keep getting confused with total surface area and area. But I think this is right. What else could have gone different? Force is the same W, the same Young's modulus, the same length. But why is I'm getting 4 by 3e, and that's what I got. Looks like I need to ask this to some other. Sometimes the Akash answer keys, they don't even give you the actual reason, guys. Okay, literally. Okay, okay. Oh, sheesh. we were so close to it, and then we kind of deviated back and put the wrong answer. That is what happens. Okay, never mind. So yes, initially the compression is E, and finally the compression is 4 by 3E. So what are they asking? Will it increase by or decrease by is what they want. Now if you've observed, it's basically increasing. By. The word by is so damn important here. Guys. So you need to basically see the difference. How much is it? Has it increased or decreased? So 4 by 3E minus E, you get E by 3. So the final compression was definitely more than the initial based on the value you got. So it's increased by E by 3. Okay, man, okay. Now that is actually a good question. And also guys, if you're doing it on your paper, then please do highlight the keywords, because I'm like underlining it with a pink pen here. So please do it too, because this is where you'll go wrong. And this is where Neet can confuse you the most, okay? Next question, I kind of got it as it was, but I didn't really know how exactly to do it. So let's do that one too. The paper autopsy is going so damn deep that I'm gonna shatter every single concept soon. Okay, the next question is the lower surface of a steel slab, and I'm sure you can see I've drawn a steel slab of length 500 mm, breadth is 400 mm, and height is 40 mm, is kept fixed, and a force of 10 power 5 Newton is applied on the upper face. Okay, now for this question, visualization is so important, and I'm sorry because that particular visualization I have right there is not worth, because I couldn't actually find it out, but visualization is so important. Okay, we need to do a steel slab with some length, with some breadth, and with some height. So I'm sure you guys know how to do the um, ultimate diagram of a cuboid kind, right? So I'm doing something like that. Okay, so it's just a steel slab. We have 500 mm, we have breadth of 400 mm, lower face of the steel slab is lower face. Why do they tell it like lower face? Oh shit, correct. Because this is 40 mm. And lower face breadth is 400 mm. Okay, right, height I'm perfect. Okay, I think that's the mistake I've done, but I think if I've visualized it properly, I could have gotten it understood better. But fine, now I've done a better diagram. So it's kept fixed basically, and a force of 10 power 5 Newton is applied on the upper face parallel to it. Acha, okay. So you're putting it a force like this, right? Now, if the displacement of the upper face related to the lower face is 4 into 10 power minus 3, so it's basically something like this. So this difference is 4 into 10 power minus 3 mm. The rigidity modulus. Okay, first off, we've done a lot of questions with Young's modulus and a few with Bulls modulus. Rigidity modulus comes very rare, so this is a really good question because now you're working on something that could be asked. So, what is rigidity modulus? Firstly, it's denoted by a symbol like eta, I'm telling you, because I think we call it eta only, but so that is nothing but shear stress by shear strain. Let's look at how to do the whole shear stress, shear strain thing. Stress is simple, it's force by area. So I'm going to divide the force, which is 10 power 5, with area, which is 500 into 400. It's only 500 into 400, right? That was my another doubt, because you have height, length, and breadth. Based on which surface you're tackling is what you need. So yeah, I think it is 400 into 500. But since it's in mm, you need to convert it into meter. So 1 meter is 10 power minus 3. Sorry, 1 meter is, yeah, 10 power minus 3 mm. So I'm going to put into 10 power minus 6. Now talking about shear strain. Shear strain, I think for this rigidity modulus there was a different kind used. And that's where I got out. So let me put the formula again. Shear strain is displacement by height. Okay. That was maybe something I didn't really know. No, I think I knew it. Fine. Because you need to find theta. And the only way you could get tan theta without hypotenuse is tan theta. Did I tell it right? Yeah, you need tan theta only. So, right, we got it. So it is displacement by height. Displacement is 4 into 10 power minus 3. Height is 40. Wait. Something is more confusing because now I will not be able to get the answer if I use this method. So let me check where it went wrong. Point 2. That makes sense. Okay, fine. Oh, yeah, got it. I was so confused. I got it, guys. Another important thing I want to tell all of you is if you're doing a question and the calculation doesn't seem satisfactory, but you know you've done the right method, please go for it because sometimes the calculation can mislead you to thinking it's a wrong calculation. I'm not going to get the right answer, but you might end up getting the right answer. So you might just be stressed, and that's why you might think so and so, but it's fine. So what if find to 10 bar? What the heck? What the heck? Why am I getting a different answer? 7. Uh, how did I get it in the exam and not right now? Okay, I don't think I got it right in the exam as well. But still, where did I go wrong? 6, 7, 8, yeah. I need 10 bar 9, but I'm getting 10 bar 6. So bad. I'm so sleepy, guys. Oh my god, still doing it. Okay, right. There was another 10 into minus 3 that I'm supposed to add. Okay, got it. Found the loophole. And also, guys, Newton per meter square. Because they're asking you the rigidity modulus. Okay, definitely took some time to find where I went wrong, but it's fine. We're here. Next question. Now, there was a lot of things that Poisson's ratio is not there, but I don't think it's a huge topic. I think we can easily do it. So, I'll be doing it right now. Before that, the previous question, I think the only thing that I would most likely forget if I would have not learned it is the fact that shear strain should be done displacement by height, because that was a part that was kind of confusing me, but it's fine. We've done it. Move on to the next question about Poisson ratio. I'll just ask ChatGPT to give me a small, you know, information about it so that no matter even if they ask a simple question or a syllabus, I should be able to answer it, right? Could you please explain me everything about Poisson's ratio from that chapter? Just give me everything that's necessary for NEET exam. Why did it hear it like boils now? No, I meant Poisson's ratio. Hmm. ChatGPT is telling me it's a very important topic and people usually forget it. Is it? Okay, let's see. So it's telling it's a very important NEET topic and it's giving me a full NEET explanation. First and foremost, understand the situation. Imagine a rubber band or a wire. If you pull it, its length increases, the thickness decreases. If you compress it, length decreases, thickness increases. So whenever a body moves in one direction, it also has changes in perpendicular direction. So that sideways effect is actually what's called Poisson's ratio. Okay. Now let's talk about longitudinal strain, which is original length L and increase in length delta L. So the longitudinal strain would be delta L by L. Talking about lateral strain, where it kind of becomes thinner or thicker. So you're gonna deal with diameter. So it's gonna be delta D by D, lateral strain. Now, what's the actual definition of Poisson's ratio? How much lateral deformation happens compared to longitudinal deformation is the question in person. So what are you going to write Poisson's ratio as? It's going to be written as lateral strain by longitudinal strain. And remember, it's only going to be a number because you've cancelled both the units. So you do not have a unit for this, so it's going to be without any unit. But other than that, it's going to have lateral strain divided by longitudinal strain. And why is there a negative sign is a question you might have. And it's important to note that there is a negative sign first off. So what is the reason is when stretched, that longitudinal strain is positive and lateral strain is negative. Because diameter decreases, so ratio becomes negative naturally. To keep Poisson's ratio positive for ordinary material, we put a minus sign. And the expanded formula is delta d by, okay, never mind. Okay, it's so pretty tiring. I'll be back. Okay, so we're back, and we just had a small break. I think I'm just gonna slide that into, and we're gonna continue. We finished three questions so far. We still had one more question. We were learning about Poisson's ratio. That's when I kind of slacked off. I was just sleepy, guys. Never mind it. I think this is why people take coffee, right? I mean, because I genuinely do not remember drinking coffee in my 2 years of preparation. I don't drink a lot, you know, because my mom doesn't let us buy it a lot because I think that's also for a good reason. But yes, let us continue. I think I just had a little bit of time for myself when I came back. There's a lot of talking about this need, guys. But imagine if you actually win in this, wouldn't people be so impressed? Like, do you even understand what I'm saying? Because I have that thing in me which tells so and so, but it's fine. Continuing with Poisson's ratio and telling you what exactly that is if you've not yet learned about Poisson's ratio. So, first off, we have, in general, if I have to tell you the formula of Poisson's ratio, which is the only thing that most likely is required, is Poisson's ratio simply means lateral strain by longitudinal strain. So write that down as, and there is minus sign, so it's minus lateral strain divided by longitudinal strain. Now what exactly is the difference of longitudinal and transverse strain? Wait 1 second, I kind of learned it before. Seem to have forgotten, but I'll get back with it. In um, the first part of the chapter, you have under longitudinal strain and stress, you have tensile, compressive, and when it comes to tangential or shearing, you have shearing, that thing, okay? And for bulk modulus, you have the volume strain and hydraulic stress. But the transverse strain, I think that's what they mean by the lateral strain. Let me just confirm that. I think you need to be aware of all these different terms that they use for a common thing as well, because who knows from which book the examiner is going to set the paper, right? Okay. Could you please tell me is lateral strain and transverse strain the same? Okay, yes, it is the same. So let's put that down as well. Lateral strain is same as transverse strain. No difference, guys. Okay. Now let's dive more into what this is all about. Now, when you see the question, it becomes very clear because definitely Poisson's ratio would be 1 if both of these are equal, and because of the minus sign, it would be -1. And thankfully, yes, that is the correct answer. I had probably just 80% clarity that that could be the answer, but I still went for it. And also, guys, I kind of figured out that in the mock exams, I don't really care a lot of about negatives, but in the NEET exam, I did, which means I need to practice that right now so that I can avoid more negative markings in the upcoming Re-Neet. So I hope you understand the situation. So cork has 0.0 ratio. Mm, I'm just checking what is important. So there are a few things that when you stretch something, the length increases, diameter decreases, longitudinal strain remains positive, lateral strain would be negative. And when you compress it, length decreases, diameter increases, longitudinal strain will be negative, lateral strain will be positive. Hence, usually the Poisson's ratio is a negative value. I think that is good enough for now. The fact that it's not there in the syllabus also gives you a choice to skip it if you don't want to. But yes, orals, that is so much about it. Moving on to the next question, which I still don't know if I got it right, so let me check that out first. Thankfully, the teacher has sent the answer key. I think the result is already up, but I'm restraining myself by seeing it because if it's a bad result, then I'd kind of feel bad. But we'll see about it later, guys. Let's first finish this. I'm not even kidding, but autopsy takes a lot of time. So our paper autopsy, I don't know how long it's gonna end because I think I've been doing 4 questions from the last 1 hour. Anyway, next question is, oh, I've gotten it wrong. This is what I've gotten it wrong, and I think understand where I've gotten it wrong because this is another most silly mistake. Okay, where have you gone wrong? Let me tell you. So basically, when pressure of 200 atmosphere. So what does it mean? It's 200 atm. That is right. 200 atm is applied on a spherical ball, then its volume is reduced by so much. So remember that delta V by V is 0.02%, right? That is also fine. The bulk modulus of the material. So firstly, you need to know the formula for bulk modulus, which is P is equal to minus P divided by delta V by V. Usually there's a negative sign for this as well because volume is usually decreasing, but even if you ignore it, it's fine. But you need to remember now, you know what's P? 200. You know what's delta V by V, which is 0.02 by 100. Now altogether, yes, you will get 10 power 6, but you've got it with respect to atmosphere. You need to convert it into Newton per meter square. So that is where the whole thing has changed. So I think that is what I need to focus on again. These are very simple things with respect to NEET, and see, this is where you can go completely ask you with respect to NEET. So I'll just see one more thing. Okay. Could you please tell me how do I convert um, okay, let me just read the question to you. When a pressure of 200 atmosphere is applied on a spherical ball, then its volume is reduced by 0.02%. The bulk modulus of the material of the ball is. Now, I need to convert that into Newton per meter square. How do I do that? Please help me with it. Yes, I'm asking ChatGPT for more clearance because I don't want to give you the wrong information, guys. Please do wait. Okay, roughly speaking, 1 atm is 10 power 5 Newton per meter square. Okay, so this is what you need to remember. So what are we going to do here? 10 power 6 we're going to convert. We're just going to multiply it with 10 power 5. You're going to get 10 power 11. So that is the answer. 10 power 11 Newton per meter square. Good. Good question. Now moving on to the next question, which I was definitely not sure on how to do it, though I've seen questions like this for the past years. I think it's time to now clear this all at once. Two equal and opposite force. Just 1 second, guys. Just give me some time. I just want to turn this. Okay. Right. The next 1 second. Yeah. The next question is. Oh wait. What the hell do I do? Yeah. So the next question is two equal and opposite force of magnitude F act on a rod of uniform cross-sectional area A, as shown in the figure. Find the ratio of shearing stress and longitudinal stress on section BC. Diagram is given, so things are pretty clear, but I just told you, right, I was very confused of what exactly shearing stress would be there. But I think now I kind of have an idea. I think let me try it once more before I look into the answer. They're asking the ratio of shearing stress and longitudinal stress. I think longitudinal stress, first up, there's no values given except one that you can find there. Okay, let me just check. Okay, so if that was the thing, then tan 60 is how much? Root 3 is to 1, so you would have root 3 by 1 for tan 60. Now that divided by longitudinal stress. Okay, wait, this is strain. It's not even. Force is the same. So stress and strain you have root 3 by 1. Now, so we're going to be the same. Is the answer fourth option? Let me just think once more if I look into the answer. I think with respect to the longitudinal one, there's no value as such. So what am I supposed to do? I think I can just be bland with it and go with the option of root 3 is to 1. Okay, let's check if we are right or wrong. We're wrong. The answer is 1 is to root 3. Now let's look into where exactly we've gone wrong. They've taken cot. Why? Okay, very confusing. Let me go check it out with some other. I'd love to use Google, which is kind of faster. If you want to upload a picture. Don't mind the sound, guys. I'm sorry. At least we need to make it like 15 questions and then a break. Sorry for that, guys. How great that even this one is giving you the wrong answer. I wish we did anyway. Let me check it out in Doubtnut. Never mind. Now I will understand. Kind of realized that my physics teacher is not there anymore. So I think this is a better chance to ask my doubts to physics teacher. Mm, how to? This is so hard, guys. This is so hard. Can't even find a single answer key that can explain something properly. They've given f by a sine square theta. What am I gonna do with that? There's a lot in it. Okay, I think final option is ChatGPT. No, I'm not even kidding. If you have the premium version of ChatGPT, very well and good. If you don't, also it's fine because you can try your best to ask all the diagram-based questions by taking a picture of it, and at least 80% of the time, it gives you an answer with clear understanding. So I trust ChatGPT for that. So could you please help me with this question? Like it looks so easy, but I don't think it's as easy as I think it is. The answer is third option, which is 1 by root 3. I don't understand how. Could you please help me with it? And also, guys, another thing about a Telegram channel that I've joined is where students like put your doubts, and like the one who knows it kind of helps you with it. So it's a good situation. So I will not be left with a situation where I don't have anybody to ask the doubts to. Anyway, we're looking into it. I think until the answer comes, I'll be seeing the rest of the questions if I've gotten the answer right. For seventh one, I kind of used a simple logic, but I don't know if it's correct. Yes, it is correct, but I have no idea what logic. I use a good logic, but I just want to verify if it's the right thing or not. So let's check that out. Let's see the next question. 8-1. Yeah, this is literal NCRT, guys. I still remember learning it in NCRT. There's a diagram where you can see a ball moving and the air lines kind of like, and that's all Bernoulli's theorem. And the rest of the options never made sense. So that was definitely what I went with. Ninth is first option. Yeah, this one is also. I think this is one was asked in NEET exam, right? But there's another question where they ask you if it's thrown, not dropped. The whole situation is different. I'll be telling that to you guys as well. No worries. Let's see how with the next. How have I done? Okay, I've gone with this. I don't think that is correct. Yes, it is not correct. It's the second option. Now, why did I go for it? Something stupidity. I mean, I kind of saw this formula to do this question right before the initial NEET 2026. I kept revising it. Yeah, this formula, like 2 root of small y of capital H minus small y. I kept learning that one formula. It did not come to use, but it did come now. And I had the small hope that I might have gotten right with. See, I didn't even write the formula anywhere because I only knew somewhere there would be a subtraction and there is 2 multiplied. That also I kind of knew it. But the rest I kind of didn't know, but I still went for it. But chances are there, but it's still a negative if you make it wrong. So think before. Okay. 11th question also is one fine. I had a small doubt about it, but then after reading it twice, I think I kind of understood. Yeah, that should be correct because physics are always like that. Moving on to 12th, it is fourth option. Yes, it kind of made sense because see, I've written it correctly. 4 degrees Celsius. See, I didn't really think a lot about what would specific volume of water blah 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 be like, but I kind of knew that it has to do something with respect to the anomalous expansion. So I think that was the only option that made sense. Though I still don't know what is the zero value for Fahrenheit. Is it 32? No, it wouldn't be 34. I don't know. Let's just check that out later. But coming back to this question that we left, I think let's be fast like this so that we don't waste a lot of time. A rod is being pulled by equal and opposite force. So inside the rod, the normal longitudinal stress is F by A, yeah, where A is cross-sectional area perpendicular to the rod. But the question is not, oh right, there is an involvement of the cross-section area. The area, I think that's something you need to work on. Yes, okay. But the question is not asking stress on the normal cross-section. It asks, okay, we need to find stress and shearing stress, longitudinal stress, only on the BC part. That is what they want us to know. Okay. So that is something I did not know about. Thankfully, it is mentioned. I think that is something I need to note down as well because it's only section BC that we need to know. Okay. Next key theory for inclined plane: when stress acts on an inclined plane, it gets split into longitudinal and shearing. Okay, so normal stress. Great. They put something else. What? Wait, let's see. I think the answer key given in my institute was a direct one because for shearing stress by shearing strength they just did cot theta, but it doesn't make sense. I don't think I want to learn it like that. mm, sigma sigma sine square theta is for normal stress, sure, because sigma sine theta is cos theta. mm, I think that's how they got it. Then you, yes. See, normal case, the direct what they've given is shear stress divided by longitudinal stress is cot theta. Why is it cot theta? Because for shear stress, you kind of write it as sine square theta. No. For shear stress, you kind of write it as sigma sine theta cos theta. And for normal stress or longitudinal stress, you kind of write it as sigma sine square theta. So definitely when you consider in those terms, you get cot theta. But doesn't make sense. Like, what am I even supposed to do with respect to the shear stress, the angle, all these things? I'm truly bad at the foundation level of physics, guys. That's why I'm suffering a lot, only with respect to physics. No, because if I compare myself with the topper with respect to physics, I still feel like I'm not that lagging. It's just that It's just about interest, guys. Forget it. The big conceptual understanding is this chapter has one very important hidden idea. When a force acts on an inclined plane, it can be resolved into component perpendicular to plane, which is normal stress, and component parallel to the plane, which is shear stress. And that is what is happening, is what they tell. Okay. Maybe this one thing I'll write it down because theory is also important. Then which is normal stress. Which is shear stress. Okay. What next? Do I have to remember cot theta for like every single kind of question like this? Would this be the only thing that is asked with respect to an inclined stuff like that? Because let me be honest, I do not know the basics and foundation of this thing, of what to do when they're asking it for an incline. So I really want you to help me with that. Yes. Now it's coming to a point which I've seen in previous questions. Like, now the basic idea is when you have a force on an incline, the component that is perpendicular to the plane would be the normal stress, and the one that is parallel will be the shear stress. But if you consider the perpendicular component, you can write it as f sine theta. And we consider the parallel component, you can write it as f cos theta. Okay? But the most hidden thing, which I think even you should know, is the fact that area also changes. Inclined area becomes larger than normal cross-sectional area. So if normal area is A, the inclined area becomes, for inclination, it would become A by sine theta. So therefore, if somebody asks you tangential stress, you'll always write it as F by A sine square theta. Okay? I think that's how they've got it. Good. Makes sense completely. And even in the component parallel to it, the case is same. So that's why now everything makes sense. Nice. Everything makes sense right now. Great. Okay. Moving on. I think we have this question. Now, talking about this question, I think used a good logic here, as you can see. Based on that logic only, I've solved the question. That in the case of the first liquid, I definitely went wrong with the sigma 1 and sigma 2, but that's fine. Unless and until I understand it, I think it's fine. So, in the first case, you can see a liquid and you put a string to it and you have a ball inside it. Now, in the first liquid, the density is 800, and in the second case, okay, sigma 1, sigma 2, good, done. Now, in the first case, tension acts upwards, mg weight acts downwards, buoyant force acts upward. So if you have to, and it's in equilibrium, let's consider that way. This was something I was thinking if I could consider them in equilibrium or not, but fine. But based on that, we have done so. Tension plus buoyant force is equal to mg. And in this case, weight is downwards, buoyant force is upward. There's no tension. Oh, sorry. I think this is something that's not an arrow, but that's a string which is holding it from below. So there is tension there. So it's T plus mg, which is Fb. Now Fb differs. Why? Just 1 second, guys. So guys, the parent just told me they've got the result of this paper that I wrote, and I'm staying in the same rank. But would I make myself up to see the result of it? I think I don't know. Well, okay, let's promise that we're not going to slack off from what we're doing, but I'm gonna see the result right before you because um why not, right? Let's check. Why am I even scared? Like, thankfully I do not go down. It's better than to not, better to stay in the same position than to go down, right? But I really want to know how much I'm scoring because I'm sure it's very less because than the previous one. But I'm really gonna feel bad because last time too I felt bad because of. It's fine. I'm not gonna feel bad after we will do the complete analysis of it. I'm scared. We're continuing with the question, guys. So the seventh question right there. So it's rho G. Assuming, okay, these are identical bodies submerged into different liquids, but we don't know if the volume of the liquid is the same, right? density is different, but we don't know about the situation of volume. So that was one doubt I had. But if I do not consider that and do rho g, I kind of get the answer of density of body, which is 900. But let me once more check it out if I've done the right thing. Because so what have they done is I need to see the formula dump there. Let me check once more. In the question for density, volume of body and volume of liquid is not different, they are the same. And let's check it out right now. And another worst thing is this website is not going to open as quick as you want to get you. No exam result found. Kya? This is not open. But I'm going to check the results if this is a situation. I don't want to go again to my parent and look at their phone. What the heck? Why are they even putting up the results? The freak. Okay. So it's basically meant for us to not see it then. So I'm not seeing it if it's not meant for us to see. Huh? Right, so my method in this question is definitely right because the Google somehow has agreed to it. And the only thing I have to remember is the volume is same in all case, because volume of body is equal to volume of liquid displaced, right? So fine, I think we can move on. Alright, so that's one thing. I think that was a doubt that I had, which is kind of cleared. But other than that, the buoyant force formula is rho Vg, which I need to remember. Next, okay, moving on to the next question. I think this question is pretty clear. I was able to do it, but I definitely need some clarity because if they would have asked some other example, I wouldn't have gotten it right. But if I have to check it in the textbook, the actual examples or the diagrams, there's a lot of diagrams with respect to this chapter, I'd say. Yeah, there is a diagram of ball without spin and with spin, and it also comes under the dynamic lift part. So I think the airplane wing also works in the similar situation. But still is a little bit okay. Everything under shore comes under Bernoulli's principle, which is the speed of efflux or Torseli's law, the venturi meter, the blood flow and heart attack, the dynamic lift under which comes the ball moving without spinning and with spin, and definitely there's aerofoil or lift on aircraft wing. I think I'll write that, or I'll ask ChatGPT now that I know it, so that it can give me some good examples. So there was a question in the mock test which gave examples with respect to the theorem to which they belong to. Like for example, cricket ball, the spinning of it comes under Bernoulli's theorem, right? So could you give more examples from Bernoulli's theorem, equation of continuity, surface tension, and viscosity? And guys, this one method that I'm doing right here would fetch you a lot even in the future. I know I'm very slow with respect to this paper analysis, or in our terms we call it paper autopsy, but let's make it right. Okay, so it's given me a lot of information. For example, Bernoulli's theorem itself is nothing but P plus half rho V squared plus rho G H is equal to constant. So the core idea is faster fluid speed, lower is the pressure. Okay. That's something I didn't know. I am really bad at this chapter, but I don't think I'll make it bad for the next Neet. Faster fluid speed equal to leads to lower pressure. So yeah, I can understand this. So examples are spinning ball. So they've also given what happens. So on one side, air speed is higher and pressure is lower. On the other side, air speed is lower and pressure is higher. So the pressure difference curves the ball, and this is not okay. The reason why it spins is because of Magnus effect. Because if you see a ball, the upper part of it, the air is very fast, so the pressure is low. But the lower part of it, comparatively, the air is slower and pressure is higher. And the pressure difference makes the ball spin. Then why do they sell you have to spin the ball? Right? What the heck? Okay, I'll ask that to ChatGPT later on, but let's finish the important examples. That's the first example. Next one is lift on airplane wings. So the upper surface air moves faster. So the pressure difference is what makes it lift above. Okay. Next good example, I think I learned this in my 11th. Roof blown off during storm. Okay, good. Next. Have perfume atomize. Oh, or spray, right? Spray also works in the same way. Nice, I didn't know it. That's good enough. Next, we have equation of continuity. So what do they tell here is flow rate remains constant. That's the core idea, it seems. Remains constant. So basically AV is constant is the formula. Smaller area, larger speed, larger area, smaller speed. Okay. Important examples, narrow part of pipe, river flow, then you have thumb on water hose. What does that mean? Oh right. We usually place our thumb while putting water to plants, no? So that they can go to larger distance and flow higher. Blood flow in arteries, nice. But I understood that it's laminar flow, right? Next we have venturi meter. Next, when we talk about surface tension, so this means, I think this also comes in the question next year, but in general, this also means that liquid surface behaves like a stretched membrane. this is due to cohesive force. I just want to check if I'm recording. Yeah, it is. Okay, next. The examples of water droplets are spherical in shapes. That's the reason. Small insects walking on water. I was actually imagining this. Small insects walking on water. Needle floating, so bubbles. Capillary rise. The fact that detergents clean clothes. Raindrops being spherical. Okay, last concept is viscosity. It's good that we're going back to the basics, but it's fine. I know it's taking a lot of time, but it's worth it, guys. Worth it. Believe me, as someone who's cracked me, it's worth it. Viscosity itself is internal friction between fluid layers. Okay. Okay. This is also reason why honey flows slower than water. And also important, streamlined bodies. They have to be streamlined so that we can cut through the fluid. Wow, I still remember that one. A ball falling in a liquid. Lubricants in machine. And you have parachute and air. The fact that raindrops reach terminal velocity. Yeah, so everything is now good. I've gotten every single detail about the important concepts of the fluid mechanics chapter, which I'm really happy about. Moving on to this question, and as I promised, I want to give you guys also the graph for which it is thrown and not dropped. And if you're throwing it, initially you're giving it a lot of velocity. So it is not actually, I think it can remain the same. But there'll be a huge increase in the velocity. Here also there is an increase. But I do have that question paper, but I don't think I'm going to go to the question paper right now. I will get it through the internet, but there is also a question where they could ask viscosity if the ball is thrown and it is not dropped. And also another important information they've given through this is viscous liquid having density less than stone. I think that is also something we need to focus on. Okay. Could you please give me a graph of the stone thrown in a viscous liquid and the difference of that as well as stone dropped in a viscous liquid?
When a stone moves through a viscous liquid, gravity, buoyancy, and drag forces act on it. I will see.
So when a stone is dropped, the initial velocity is zero, and the thrown, if it's thrown, then the initial velocity is more than the terminal velocity. And when it's dropped, it actually accelerates downwards, but if it is thrown, then it decelerates downwards. Viscous drag force for when it is dropped will be zero, but if it is thrown, it will be high. And the final viscous drag force will be equal to gravity if it is dropped, and it will be equal to net gravity if it is thrown. Terminal velocity when it is dropped, it will reach from below, whereas here it will reach from above. So I think the third graph would what mean about the situation. Let me clear things up a bit so that we don't get confused. So I actually didn't know it that much, but it's true that it starts from high, but it later on decreases. The velocity decreases, but it starts with a high velocity, which is more than terminal velocity. I think that was a good point that we took up today, right? Engakalam dia, engakalam dia. So the graph would be something like the third one for if it is thrown, and for the initial part, if it's dropped, then it's going to be something like this. And it also starts from zero, guys. That is another thing you need to know, when it's dropped and when it's thrown. Yep. 10th question. Most of the times in the answer key, they just tell it as fact. Anyway, moving on. Please just give me a sec. Okay, let's go to the next question. So the question tells a tank is filled to a height h, and the range of water coming out of the hole, which is at the depth of h by 4 from the surface of water level, is. Mhm. If it's from the surface of water level, it means it's from the top and not from the bottom. Now that is something again which I missed in this question. I have missed it anyway. And what is there in this question is you need to visualize the whole thing. That there is a tank filled with water up to a certain level, and the height until which it is filled would be h. And now there is a hole through which water comes out, and we need to find what is the range of which the water comes. And the height is basically h by 4 from the top. So what is going to be in the bottom is 3h by 4. And you need to find the range. So if you're finding the range, there is a direct formula which you can apply, which is r is equal to 2 root small h of capital H minus small h, which is 2 into 3h by 4 and h minus 3h by 4. So let's see what is answer. H by 4 into 3h by 4 root. So I can bring 4 out, h out and root 3. So the answer is going to be root 3 by 2 into h. Now that is something I didn't know, and all we have to know in this question is a simple formula of 2 of 2 into root of small h of capital H minus small h. 2 into root of small h of capital H minus small h. Small h. It's simple. Root of 2 consider physics 1 so 2 root of small h of h of h minus capital H minus small h. So that's the keyword. Okay, moving on. I think the next question is pretty clear. Let's just read it once more and move off. So the question tells surface tension is a force per unit length acting in the plane of interface between the plane of liquid and any other substance. I kind of imagine the fact that when you pour water on certain material cloth, they don't stain it like instantly because it kind of flows out like beats. So I think that is also the same reason, because surface tension is a force per unit length acting on a plane of interface between planes, liquid and water. So otherwise, I keep forgetting the surface energy, surface tension formula. I think I'm going to say that. The statement B tells surface tension is the extra energy that the molecules at the interface have as compared to molecules in the nucleus. This is I think this is the first thing that my teacher had taught when he started with the viscosity, sorry, surface tension thing. So the only thing I'm just going to learn in this part is something that I forgot initially, which was surface energy formula. Could you please give me the formula for surface energy and surface tension, all these stuff? When is mommy gonna come home? Okay. So basically, surface tension is a force acting per unit length perpendicular. Okay. Surface tension itself means F by L, and remember, surface tension is not same as force, but it is same as force per unit length. And I think this is something I kind of realized in the last phase of the previous name that I wrote. So, hmm. Okay. Moving on. So the basically unit is Newton per meter, guys. That's what I wanted to tell you. Fine. And when we talk about surface energy, it's nothing but work done to increase surface area by unit amount. What does it mean? What does it even mean? Work done to increase surface area by unit amount. So it's going to be work done by area, which is joule per meter square. Yeah, I think this is something I forgot, but fine. Work done by area, surface energy. Basically, energy by area. Fine. And surface tension is force by length. Okay, it kind of makes sense right now. Oh, sheesh. For liquids, surface tension, yeah, I think it makes sense, is equal to surface energy per unit area, because the dimensions are going to be the same, right? Oh, okay. So that's how you get the formula W is equal to T into del. Oh, right. So this is where I was very confused of. The surface tension and surface energy formula is almost like the same. Right, I think now I can understand everything. Nice. So film, it has two surfaces. That's why you multiply two into surface tension by area. So surface tension and surface energy is kind of the same. So hmm, everything makes sense. Everything makes sense. Everything makes sense. No, everything makes sense. No. So you could find force, you could find work done, but you can still use the same surface tension. And that's how beautiful it is. And the most high yielding concept of this chapter is pressure difference in a liquid drop, which is 2T by R, soap bubble, which is 4T by R, and air bubble, which is 2T by R. Okay. Capillary rise formula. Okay. The best thing with ChatGPT is that if you ask it one doubt, it's gonna teach you the whole chapter. And I think I asked for it before, that's why. But I think that's something that helps me remember and reinforce all the formulas that I already know about. Capillary rise h is equal to 2 capital T cos theta by rho r g. Most important conceptual distinction. So capillary rise is 2 into surface tension cos theta by rho r g. I don't think I'm remembering all these formulas. I think I need to start working on by hearting physics formulas because I did try to do them the day before the paper and it kind of worked and got me 100 plus, but I'm where I am right now. 2 capital T cos theta by rho r g. 2 capital T cos theta by rho r g. 2 capital T cos theta by rho r g. How am I going to remember and by heart these? I'm going to flashback. My star, open, fly. Okay, next question. This one, it's asked ChatGPT about it. The specific volume of water is minimum at option 1 there is 4 Kelvin, option 2 there is 4 degree Fahrenheit, option 3 there is 39.2 Kelvin, option 4 there is 39.2 degree Fahrenheit. Option 4 is the answer. Now what do I actually look for in this question? Could you please explain me in detail? Physics drains our planets. But I think that's a need my go-to for the subject who's pretty good. I did them in the right way. You need to know about anomalous expansion of water. In fact, that water has maximum density at 4 degrees Celsius. It's not 0 degree, guys, it's 4 degrees Celsius. So, that also means specific, minimum specific, sorry, volume of water. And if you have to convert it, and also, guys, the minimum of Fahrenheit is 32 degrees Celsius. Sorry, Fahrenheit. How did I get that? No, right. I shouldn't use a normal method of plus 4 because you can't convert degree Celsius and degree Fahrenheit like that. You need to use a different method. There's 120 division, right? How many divisions again in Fahrenheit scale? 120? Like it's from 32 to 212, right? So it's 180. Anyway, 2 fives are 2 nines. So you have 9 into 5 plus 32, which is D. 5 sevens are 35. So it will be 39.2. Yes. Got it. Fine. Okay. Now, I think I know where exactly my blunder was there, but other than that, everything is fine. Shall we move on? I'm just gonna take a break and be back.